Now we are going to discuss about the laws of chemical combination. Very important. Okay. So see, during the chemical reaction, whenever the chemical reaction takes place, they obey certain laws. Okay. So first we have to understand what is chemical reaction is. Okay. So chemical reaction is nothing but the process in which one kind of substance that takes part in the process and form new type of product. New type means different in properties like physical and chemical properties. Okay. So whatever the component which take parts in chemical reaction are called as reactant. Okay. So I'm writing here reactant. Okay. So those components that takes parts in chemical reaction are called as reactant and they form the product. Okay. The final substance which is formed during the reaction are called as product. And in previous standard, you already gone through that how to write chemical reaction. Okay. Like in extreme left hand side, we are writing a reactant. So this is left hand side and this is right hand side. Okay. And in extreme right side, we are writing the product. If we have more than one reactant, so we are separating them by positive sign. Even product also, if we have more than one product, so we are separating by positive sign. And that arrow which is always directed toward the product, that arrow represents the direction of chemical reaction. It represents the direction of chemical reaction. That means chemical starts from reactant and proceeding toward the product. Okay. So this is again very important. We have to understand. And one more thing. See, whenever we are writing the reactant and product, so we had to mention their standard state also. So I'm just giving you one example for the reaction. Suppose we have sodium, it is in solid state. When it reacts with chlorine gas, okay, so we had to mention like chlorine and its standard state. So it is gaseous form. And we are taking like half mole of it. And when they react, they form sodium chloride, and which is nothing but the solid salt. Okay, so see here, we had two reactant here, first and second. So we have used here the positive side. Okay, and one more thing, suppose if we are using any allotropic form, so we had to mention their allotropic form also. Suppose we have carbon and we are using graphite form. Okay, so we have to write graphite like this. Okay, graphite, and we are burning it in presence of oxygen gas. And see, the process is burning, so we have to write burn here. Okay, and they form carbon dioxide gas. Okay, if it is gaseous product, so we had to mention the arrow which is directed upside. It means the gases is releasing. If suppose precipitate is formed during the chemical reaction, so we had to like write arrow which is downward side. So it is used for precipitate. Okay, it is going to deposit. So likewise, this is nothing but the standard chemical reaction. Now we are going to like learn the first law of chemical combination, and which is the law of conservation of mass. So I want everyone had to take a screenshot for that. Then we are moving further. Done?
Also 1 minute.
Okay.
Done.
Okay. So first, so in chemistry, we had total 5 laws for chemical combination. So out of which first we are going to learn, and which is the law of conservation of mass. Law of conservation. Conservation of mass. Okay. So the name itself have its definition, beta. The name itself, see, It is conservation, means whatever we have, it is going to be constant. Means it is not going to change. And what is not going to change here? The mass. Okay, the mass. So we have like definition here only. The in any chemical reaction, okay, in any chemical reaction, mass of the reactant and product is going to conserve. Okay, or we can say the mass neither gain nor be lost during the chemical reaction, hence the mass is conserved. So we can say the total mass of reactant is always equals to total mass of product. Is it or not?
Yes.
Yeah, so I'm just giving you little information about that law. Okay, so this law is given by Lavoisier, you know, Anthony Lavoisier. It is also called as the father of modern chemistry. Yeah. Okay, Anthony, you can say A Lavoisier. Okay, it is also called as the father of modern chemistry. Very important. Father of modern chemistry. Okay, and who is called as the father of coordination compound? It is also the part of chemistry only. Warner. Okay, Warner. Okay, so we are not going to discuss that. We are going to discuss here about the Anthony Lavoisier. Okay, who has given this law of chemical combination. Okay, so I'm writing the statement for that according to the law. According to the law. Okay, so what is going to be statement for that? Mass can neither be created, it is B, neither be created nor be destroyed. Okay, during the chemical reaction. During the chemical reaction. Chemical reaction. Okay, so mass can neither be created nor be destroyed during the chemical reaction. Hence, so this is the statement. You can say the law states that mass can neither be created nor be destroyed during the chemical reaction. Okay, therefore, okay, the second point I'm writing, the mass is conserved. The mass is conserved. Okay, therefore, according to the statement, okay, according to the statement, what we can write according to the statement? Mass of reactant is always equals to mass of product. Is it, everyone?
Yes.
Yes.
Yes. So again, I want you to take a screenshot for that.
Written and copies.
Okay. So done, everyone? I'm scrolling
Yes.
it. Okay. So for that, we are going to understand one example also. Okay. So see, in order to like calculate whether the mass is equal from in both the side, means in reactant side and product side, what you have to do? You have to just calculate number of atom in a reactant side and product side, they must be equal. Okay, so I'm writing here. Hence, the number of atoms on reactant side and product side must be equal. Must be equal. That's all. Okay. Okay, now second law. So any doubt here? Everyone? Do reply.
No, sir.
No, no? Okay. So now we are going to discuss the second law, and which is the law of definite proportion. Okay, the law of definite proportion. Okay, so see, the definite proportion is nothing but, see, suppose if we are going to collect different sample of water. Okay, suppose I'm just taking one example here. First we have to understand example and then we will write the statement for that. Okay, so suppose we have water, water from different sources, water from different source. Okay, like first we have water from the laboratory. Okay, suppose in any chemical reaction we got water. Okay, so we have collected it and we have to observe that. Okay, second, like I'm taking 5 different sample. Second, rainwater. Fourth, well or tube well water. Okay, fourth or fifth one, I'm taking distilled water. Okay, it is nothing but the laboratory one, or you can select any sample water, or instead of that you can have ocean water. And one more, 1 2 3, it is 3, it is 4 and 5. Water of river. Okay, so see, I have taken beta 5 different sample of water. If I will understand, or if we are going to observe the chemical combination for each water from different sources, there will be 2 hydrogen and 1 oxygen, right? 2 hydrogen and 1 oxygen.
Yes.
So here the ratio of atom of hydrogen and oxygen. Okay, so I'm calculating here 2 ratios. Atomic ratio. Okay, hydrogen H2 oxygen. So it is 2:1 for all. Is it, everyone? Okay. Going to calculate atomic mass ratio. Okay. In H2O,
2:6 and
mass of hydrogen is 1. Mass of hydrogen is 1, but we had 2 hydrogens, so total mass will be 2. And mass of oxygen is 16. If we can write like simple ratio, so 2 1 is 1 and 2 8s are 16. So we have 1:8 ratio. So again, hydrogen H2 oxygen, the mass ratio will be 1:8 for all. Is it, everyone?
Yes, sir.
Yeah, that means, okay, that means whenever we are getting they are exactly at the definite proportion from different sample of the same compound. This is called as the law of definite composition or definite proportion. Okay, everyone?
Yes, sir.
Yeah. Okay, so I'm going to write the statement for that. Okay, see, a given compound, let me change the color, a given compound always contain exactly the same proportion someone is in waiting, no, wait a second. Exactly the same proportion of the element of combining element by weight, or you can say by mass also, the thing will be the same. Okay, so this is called as the law of definite proportion. You can have like different example also. Suppose we are burning the coal in presence of oxygen and we are getting carbon dioxide. So this source is from the coal. Suppose we are dissociating calcium carbonate CaCO3 and we are going to dissociate that. So we will get CaO, okay, plus again carbon dioxide. So we had like same compound called carbon dioxide, but from different sources, right? If you will again calculate the atomic mass ratio of carbon and oxygen, you will get the same. Okay, but the compound must be carbon dioxide. You can take from any sources, the mass ratio of the combining element will always remain same. This is called as the law of definite proportion. Again, I want everyone had to take a screenshot for that.
Sir, it has to be only by mass, right?
Yes, mass, or you can say atom also. Atomic ratio you can also calculate.